Hey guys, welcome back to our channel. In this today's lecture, we are going to know about what is part repartition and coalesce and how it is different from each other, and at what times we have to choose which type of operation we need to use. So first, let's deep dive into each and everything. Repartition and coalesce. These are two different Spark operations used to enhance the performance and optimize the Spark jobs, right? But let's understand what is repartition. Repartition and coalesce both are used to changing the number of partitions in data frame or RDD, like from existing to higher or lower. But each and everything has a specific purpose. First, let's understand what is repartition deeply. Repartition used to increase or decrease the number of partitions in the existing data frame. Because, but when we use repartition, it reshuffles the full data, redistribute the data across the nodes, and it performs a full shuffle across the cluster. So, after repartitioning, the data will be evenly distributed among the nodes. So you can find that each and every partition has a equal number of data sizes, and it is more expensive than Coalesce. Why? Because data need to be moved between the nodes, right? So it is much more expensive, but it is efficient when it comes to your processing because data is parallelly distributed across the cluster. So it enables more parallelism and it gives a efficient performance by using this repartition. And this is the example like how we can use this repartition. We have got repartition of one. So we'll get more details in our hands-on session, no problem. And next, what is coalesce? Coalesce is used to only to reduce the number of partitions from the existing partitions in the data frame or RDD. It doesn't perform a full shuffle of the data. Instead of that, it measures the number of partitions already existed in the data frame and moving the data between executors are minimized. This is much faster than the repartition because it doesn't require a full scan. Alright. And then now understand when we go for repartition, when we go for coalesce. Alright. If you want more parallelism and your data should be distributed equally, then you can go for repartition. But if you want to minimize the number of partitions, like when you're writing the entire data after the processing, you want to save the data like a one partition, you can go with the coalesce. But be careful while using the coalesce because it doesn't reshuffle the data, right? So if few skews having more data, then it leads to a skewness of partitions. So I should be careful while using coalesce. Choose wisely when you want to use partitioning or coalesce. Based on your requirement, choose the suitable one for your performance. If you want more performance and more parallelism, go with the partition. Or if you want to write your data in only one partition or any few number of partitions, go with coalesce. Okay. First, let's understand with our hands-on examples. Now let's understand what is Now let's understand how to use repartition and coalesce in our real life with a hands-on experience. Okay. Here here I imported a Spark session to start the Spark application and I initialize Spark session using Spark variable. I have predefined data, employee data and the schema for that employee data. It has a columns like ID, name, department and salary. I try to create data frame using this data and the schema. Data equals employee data, schema equals to employee schema. So now let's try to display this. If you observe this data is displayed. Now let's understand how many partitions this data frame has. Data frames doesn't support getnum partitions method, so that we have to first convert this data frame to RDD, and then we perform on top of this getnum partitions. Getnum partitions. If you observe this, the data is divided into four partitions, right? It's default. So if you want to increase or decrease the partitions, we use repartition. Let's repartition the data. Df dot repartition. First, let's try to decrease the number of partitions. So I'm giving 3, and then try to display the number of partitions in data frame 1, so that sorry, if you see this, you can observe that we get 3 partitions, means the number of partitions are reduced from 4 to 3. And if you want, we can increase the number of partitions also. So I change the number from 3 to 6, and I am trying to get the number of partitions. Now it displayed 6. So like this, repartition used to increase or decrease the number of partitions in the data frame. But if you use Coalesce, we already observed that the default number of partitions are 4. If we try to increase the number of partitions from 4 to 6, it should not change the number of partitions, right? It should give 4 only. See, it gives only 4. Why? Because Coalesce is used to only to reduce the number of partitions from the existing partitions. So if you give 2, it gives only 2 partitions. By using this, we can understand that Coalesce is used to only reduce the number of partitions. It doesn't perform full distribution of the data, and it measures the number of partitions, and it gives only a required number of reducing partitions, right? This is all about repartition and coalesce. Thank you.